Hello students, in this lesson let us study about the basic runway length. What exactly is basic runway length we will see, and then there are three cases which are considered, that is the normal landing, normal takeoff and the stopping in emergency. So based on this we will decide or discuss about the basic runway length. So to get started with, so the length of the runway based on certain assumptions are known as your basic runway length. So what are those assumptions? Let us first see, or what we can tell it as assumed condition. Length of runway based on the assumed condition. The first one is that there is no wind blowing on the runway, right? So this we will consider the first thing. Second thing we will consider is that your aircraft is loaded to full of its capacity. Okay, that is the second thing we will consider. Next is the airport is situated at your sea level, right? Next, what we will assume is that there is no wind blowing on the way to destination also. No wind blowing on the way to destination. This also we will consider. Next, the fifth criteria that we consider is the runway is leveled in the longitudinal direction. Okay, or in other words, we can tell that it has zero effective gradient. Zero effective gradient. Your runway should have zero effective gradient is what we will consider. Next consideration is the standard temperature is maintained along the way, and also a standard temperature of 15 degree exists at the airport. Okay, so these all conditions we need to assume. Actually practically these will not be happening, but we have to assume these when we are calculating the runway length, and that length, when we assume all these things, is known as the basic runway length. So the manner in which an aircraft actually performs the landing and takeoff will decide on a large extent, or that is the factor that will decide the length of the runway. So the following three cases will be considered. So what are that? The normal landing, the normal takeoff and the stopping in emergency. So let us see how to calculate each one of them. So if you see in the figure, the aircraft should come to stop. The aircraft landing here, say from above 15 meters. So it should come to the stop position when at the 60% of landing distance. So total landing distance is from here to here. So at 60% of landing distance, it has to come to stop, assuming that the pilot makes an approach at the proper speed and crosses the threshold of the runway at a height of 15 meters, right? So the beginning of the runway portion to be used as landing is known as the threshold. Okay, so this portion is called as your beginning portion, which is used for your landing is called as your threshold. So the runway of full strength pavement is provided for the entire landing distance. From here to here we need to provide a good runway, right? So basically what is normal landing? Normal landing is nothing but your vehicle should come to stop at 60% of the longitudinal distance. Then that particular length is called as normal landing. Moving ahead, next one is your normal takeoff. Now what is this? The takeoff distance, also it is known as your TOT, must be for a specific weight of aircraft. Okay, 115% of the actual distance the aircraft used to reach a height of 10.5. This is called as your takeoff distance. Means what? See here. No, before that we will see one more thing, that is your LOD. What is LOD? LOD is your lift off distance. See, LOD is lift off distance. That is the point from where your aircraft is being lifted, right? Then 115% of LOD is a point here, right? Then there is a distance for an aircraft to reach a height of 10.5 meters here. If you observe this one. So from 115% of LOD till here, the clear way should not be more than half of this distance. Still here, this one is known as your takeoff distance. Okay, so if you observe in this diagram, it is very clear. So from here to here is your runway, and from here to here is your clear way. Okay, so this is the plan if you see from the top. So if you observe, the clear way width is 150 meters minimum, that much should be there. So normal takeoff requires a clear way which is defined as an area beyond the runway, not less than, this should not be less than 150 meters wide, and this should be centrally located from both the sides of the central line of the runway. This also should be under the control of the airport authority. Okay, so it is expressed in terms of the clearway plane extending from the end of the runway with an upward slope not exceeding 1.25%. It should have, this particular region should have an upward slope of 1.25%, should not exceed this. This should be the maximum slope which we can give. Okay, so it is to be seen that the clearway is free from any obstruction. This should not have any obstruction, and the clearway should not be more than one half the distance between, see if you observe shown here, see this is clear way, should not be more than one half the distance between 115% of liftoff distance to takeoff distance. It should not be more than this, right? The next and the last one is the stopping in emergency length. So for the engine failure case, the takeoff distance is the actual distance required to reach a height of how much? 10.5 meters with no percentage applied, right? Here we are not applying any 115% if you observe, right? So this is your lift-off distance. From here it is getting lifted, and this to reach 10.5, this will be your takeoff distance. If you observe, this is your runway. This is where your engine has failed. Say for example, this is where your engine has failed. From here to here, this is called as the accelerated stop distance, and this is called as decelerated stop distance, right? So this much of the length is called as the stop way, and from here to here this is called as clear way. If you observe here, same like previous one, but here there is a stop way also in the clear way, and also here also clear way distance should not be more than half of the distance. Okay, so it also incidentally recognize the infrequency of the occurrence of your engine failure. So in case of engine failure, sufficient distance should be available to stop the aeroplane rather than to continue the takeoff. So this distance is known as the accelerated stop distance. Okay, so it is required to provide a clear way or a stop way or both. In this case, the stop way is defined as the rectangular area of the end of runway. So at the end of runway which comes in your clear way, this rectangular area in the direction of the takeoff. This width of your stop way should be at least the width of your runway, but it's sufficient to take the load of aircraft without failure. Normally the clear way should not be more than half the distance between your takeoff distance and the liftoff distance. All the above three what we have considered, no, this normal landing, normal takeoff and stopping in emergency, these all should be considered for the jet engine aircraft. So for the piston engine aircraft, only the first and the third can be considered. Will not need the second one, that is your normal takeoff if you're going for a piston engine, right? Normally we have to calculate the basic runway length using all three, that is your normal landing and your normal takeoff and your stopping in emergency, and the one which will give the longest of three should be taken as your final runway length. Okay, so based on all these three we have to calculate, and then we have to take the longest as the final runway length. So we will do the problems related to this in the further coming classes. So hope the discussion on the basic runway length is clear to you now. Thank you.